Very good morning to one and all dear students. Today we begin the first session of our pre-placement technical teaching program, Practice for Perfection. The main idea, as we have already spoken with the as we have already spoken with CRs, DCRs, is that we need to get hands-on practice so that you will be able to hone your skills and prepare yourself for the upcoming placement sessions. We will be starting with C programming, though it may seem to you initially that you have already done it. It is very simple. You can do it at the time of placements. But I sincerely urge all the students to get hooked to the screen during the scheduled hours and see to it that you all put hands on practice and increase your level from basic to intermediate and intermediate to advanced. I hope that you will participate in large numbers and you will gain advantage of these training sessions. Wish you all the best, happy and enjoyable learning for the rest of the period. Thank you. I now
Thank you.
request Krishna sir to give his insights on this training schedule.
Am I audible?
Yes,
Yes,
sir.
yes, sir.
Yes. Hello, good morning, students. It is good that it's good to see that many students in good number they are registered for this pre-placement training sessions. We want you to learn, though you feel that you know the basics and all that, but we want you to learn those, brush up those fundamentals, and as Madam said, have hands-on practice. That is it will help you to get a job of better package. We want everyone to have a job of better package. So already companies have started inquiring about the dates for the interviews, and it may happen that maybe in the end of this month or first week of next month there may be a company coming to the campus, and that is a company with very good package. So I wish you all the best and happy learning. Thank you. Yes, ma'am. Over to Mr. Deshpande.
Yeah, yes, yes. Thank you, Krishna sir. Thank you, Varsha madam. And good morning to one and all, my dear friends. So I welcome you to the pre-placement session on C programming. And then rightly said by Krishna sir, the practice makes men and women perfect. So the very purpose of this pre-placement session is okay, just to again revisit all the concepts probably you might have come across okay in your tenure 3 years of engineering. But I'll try my best okay to make this session as interesting as possible. So my dear friends, it is almost 50 years of dominance, and that is the reason this quote is very much acceptable and applicable. After all these years, the world is still powered by C programming language. And then if you look at, there is an evidence for this. If you look at the survey conducted by the TIBE, the importance of being earnest, and particularly if you look at, okay, 2020 scenario, and you'll find that, okay, the C programming language from the popularity perspective as well as the acceptance perspective is regarded as okay at first rank, and it has surpassed Java and Python also. But then we know that okay, every programming language has its own application areas. So mainly when it comes to C programming language, we know that it is meant for system programming, especially for developing all those tools where which are supposed to directly interact with the hardware. And then there is a reason behind the popularity of and the dominance of C programming language. If you look at the major operating system platforms, the kernel component of these operating systems, it has been developed and implemented by C programming. The major component, the major section of the kernel component is implemented by C programming language. And this is not only restricted to the operating system platform. It is also applicable to the databases platform. Okay, you talk about an Giant, Oracle, and MySQL, and MS SQL Server, PostgreSQL, and open source. So most of these applications, they are coded in C programming language. And with the advance of IoT, and then okay, the disruption caused embedded systems gaining importance, you'll find that C programming language is regarded as one of the best suitable language when it comes to embedded systems, obviously along with other companions like Python and so on and so forth. Okay. Now, you may be wondering, okay, is what is there lying for us in the journey to the agility? So my focus obviously will be spending a time on those aspects where we are supposed to spend a time. Okay, it's worth spending time, I can call it as, and some basic fundamentals. As long as you guys are comfortable, I will see to it that I'll not be spending too much of a time, obviously with your consent. If you have some queries, if you're raising queries, will be trying to address the query. If not during the online session, but then towards the concluding part of the session, we will try to address all the significant queries. So, in our journey, I'll be talking about the basic fundamentals and the control statements and the functions, because function is regarded as one of the beauty of the C programming language. It allows us to decompose the problem. We will be talking about homogeneous collection array, and then okay, again, one of the most powerful feature of a C programming language, which is a pointer which allows us to directly go to the memory level and okay, do the manipulation at the memory level. We'll be also commenting on user-defined data type, something like an structure, union, enumeration, heterogeneous collection, which allows us to okay, prepare our own dish by using our own ingredients, and depending upon okay, the application what we will be dealing with. And then one more thing which is very important, especially when it comes to an okay, memory conservation. So dynamic memory allocation. So we'll be also trying to understand okay, how we can really save upon a memory, and try to use this memory in a optimal manner, because the dynamic memory allocation ensures that as much memory we require, only that much will be made available, no less, no more. Now, my dear friend, finally, what we from our side would like to ensure you that in your endeavor, we prefer, we as an Vidyalankar institution prefer to be your companion. Now, coming to the historical perspective, this is very much required. A tribute to great Denis Ricci for his efforts for developing this beautiful programming language, which has happened at Bell Laboratories in early 1970s. So, not talking about too many features of C programming language at the beginning, but what right now I can tell you is that it is a general purpose programming language. It is case sensitive. It discriminates in between capital and small form of a letter. It offers us some basic data types along with other categories of data types, something like int, float, double, character is there, char, char, the way we pronounce, and we have a void. And then obviously y2 for the real category, float and double. So there is a trade-off, okay, and everyone knows, I believe you people knows, the trade-off lies in between, okay, how much of an range and how much of an precision these data type float and double they are capable of supporting, and then in turn on how much of memory will they will be consuming. So there is a trade-off. So more of a range, more of a precision, obviously, okay, more of a memory. Then we'll be also talking about and modifiers, qualifiers. So we have these four qualifiers supported by C programming language. So we have an short, we have long, we have an unsigned, we have an signed. So sometimes when the need arises, when we realize that the range supported by the current data type, what we are planning to use, say integer, is not sufficient and for our application. So what we can do is that we can widen this range. We can stretch this range by qualifying, by applying a qualifier long. So long int becomes, it starts offering more of an range, and then obviously it comes with a cost tag, when it is offering us a wider range, obviously it will be consuming more of a memory. So that more of a range, more of a memory. This relationship is always there. Sometimes it may happen the range supported by the data type, and we realize that this much of an range, something like from minus this much to plus this much. When it comes to an integer and typically a 2-byte representation, so I can say that it is minus 32768 to plus 32767. So this becomes an range, the two extremes, and we realize that this much of a range really is not required. So we can use and short as a modifier, and what we can achieve by doing this obviously is we can shorten the range. And what benefit we will be enjoying by doing this, we will be making our program to consume less of a memory, exactly half the memory what int consumes. Now, one more feature, it is C language is function-oriented programming language. It supports preprocessor directives, hash include, hash define, and then there are many. And these preprocessor directives, why they are called as preprocessor directives? Because okay, they are processed before the compilation begins. So this is something about very simple and very basic features of C programming language. Now coming to a bit of insight on basic data types. So these are the data types. You have a tabular representation in front of you. You have a name, and we have basically okay the type of data. The data type is meant for representing. So we have char meant for okay representing characters. It consumes 1 byte, and if it consumes 1 byte, the range it is supporting obviously when it comes to a signed character. So my dear friend, this signed qualification, the data type char need not be preceded by this qualifier sign. Even if you don't write down sign, by default the representation is always an signed representation. And the fact remains, the practice of using signed as a qualifier now has gone obsolete. So you never will find that okay signed character, signed integer. Just writing down int or character okay will suffice. So when it comes to an char, it supports a range of minus 128 to 127. And when we write down unsigned character, so obviously it becomes 0 to 255. The negative section will get reflected to positive side, and the smallest number becomes 0. Now, one more thing I would like to tell you, with the assumption that you guys knows this, when it comes to an integer, so especially when I'm talking about an integer, the negative numbers are represented by using 2's complement representation. And okay, just for an illustration purpose, I'll be showing you one simple document. Okay, look at this. So this is how basically okay the negative numbers are recorded by using 2's complement representation. I'm using character because the fact remains, and what I achieve by using a character data type here is that I need to show you only 8 bits because character the size is 1 byte. Otherwise, okay, had it been a case if I go for an int type, then I need to show all 16 bits. It becomes a time consuming process. And then okay, these 8 bits are sufficient enough for we to really understand the concept. And one more thing, my dear friend, the characters are internally recorded in form of an integer only, and then okay ASCII values are used for recording. So everyone knows okay for appearance wise it is a character, but when it gets recorded in a memory, it gets recorded by using an ASCII code. And then okay normally there is a practice of saying, especially you might have come across this in your first year, कि थोड़ा सा okay कुछ characters का for some characters we should better remember the ASCII values. So I assume that you still remember okay those values. Capital A का ASCII value is 65, small a happens to be 97, 0 happens to be 48, and space ka ASCII value is 32. And then okay I assume that you know this difference also. So if at all I try to show you something like this, and if someone asks us okay you tell me what is the difference in between 0 and this 0, so these two things, okay, these two things, and then we are required to okay comment upon the difference in between these two. So I assume that you know. So this 0 included within a pair of single quotes is a character constant, and this 0, just writing down 0, is a number, it is an integer constant. So if I talk about 0 included within a pair of single quote, so it is actually 48, which is an ASCII value of 0. And then this 0 itself is a 0, the magnitude is 0. So if I do it something like this, if I write down 0 plus 1 here, and if someone is asking me, tell me the result of this, I will write down 1. And if someone asks us, okay, what will be 0 included within a pair of single quotes plus 1, so obviously I will say that it is 49. I assume that this is something what you know. Now coming back to basically, okay, the illustration part, a ka value is set to minus 52. So what I will do is that I will first write down 52 ka magnitude. If you look at this is binary representation of an 52. So 32 plus 16 becomes 48. 48 plus just wait. 48 plus 4 becomes 52. I am writing down, okay, the magnitude of this. And as I said that negative numbers are represented by using 2's complement representation. Now a ka value being minus 52, what I will do is that I will take a 2's complement of this, okay, magnitude part. And how to take 2's complement, you know, okay, there are two ways of doing this. The simplest one is you start moving across the bits in a right to left manner. So I will start my journey from 0. So 0, 0, and then I will encounter 1. So you need to keep moving and copying the bits as it is. 0, I copy 0 as it is. 0, I copy this 0 as it is. I am copying this 1 as it is. And you keep doing this till you don't encounter, okay, the very first 1. So now what I'm doing is that 0 ko copy kiya. I copy this 0. 1 I come across. I copy this 1, and then, okay, the journey of copying the bits as it is comes to an end. Thereafter, what I need to do is that I need to invert and then copy. So this 0 now when I'm copying down becomes 1, 1 becomes 0, this 1 becomes 0, 0 becomes 1, 0 becomes 1. And what I get by doing this is an 2 complements of, okay, this number, the one which is above, the binary number, obviously. This is one way, the simplest I believe. So in a nutshell, you need to start a journey from right to left. You start copying the bits as it is till you don't come across the very first one. You copy the very first one as it is, and thereafter you invert and then copy. The other method, a very standard method, is, okay, you first obtain the ones complement of the given number. So 0 becomes 1 and 1 becomes 0. And then you add 1 to it, and what you get is an 2's complement representation. And now to summarize this, so when it comes to number, integer number I am talking about very specifically. So integer is an umbrella for a character also, because character constants are internally recorded by using an ASCII value, which happens to be an integer numbers. So when it comes to deciding the range, if W is the width, iska matlab hai int ka agar size 16 hai, so W is a 16. So how to find out the range? It is minus 2 raised to W minus 1 to 2 raised to W minus 1 minus 1. This becomes a range when we are dealing with signed representation. When we are required to deal with unsigned representation, so obviously, okay, the smallest value happens to be 0. And from 0 to all, now W bits will be contributing in the magnitude. So it becomes 2 raised to W and then 1 minus, okay, because we start counting from 0. So this is how we can, okay, settle down with the range. Now going back to, I assume that you're okay with this. Now coming back to this data types. So now to summarize, we have an integer, and then, okay, we have a long integer. Now when we write down long integer, you will immediately, okay, notice that now long demands double the memory, but it also, okay, supports a considerably wider range as compared to integer. So integer is minus 32768 to 32767, very chotu in front of, okay, this sign ka wider range what the sign represent, sorry, for the long is offering to us. And same thing for float. Internally, my dear friend, floating point numbers are internally represented by using IEEE floating point representation. So right now I will not take you into the details of that, but then it is a different way of recording by giving a consideration to the mantissa part, the sign of the number, as well as the the exponent part. So the range, roughly speaking, this is not very precise range. It is an estimate. Roughly speaking, float ka range is too much. Okay, it is something like of the order of 3.4 multiplied by 10 raised to minus 38. I'd like to correct this. I will say this is minus. I am not talking about the magnitude, and this is minus, and this becomes plus, and this is 10 raised to 38. So this becomes basically the range of what we can call it as an float. So it is minus 3.4 multiplied by 10 raised to 38 to uh, 3.4 multiplied by 10 raised to 38. And same is the story here. So for double, this range is tremendous. In fact, if you just look at this, it is absolutely a widest possible range. And then if you look at a long double, it is too big basically, in comparison of double also. So it is minus 1.7 multiplied by 10 raised to 308 to 1.7 multiplied by 10 raised to 308 and blah, blah. And my dear friend, again, I'm repeating this. Basically, the ranges, what I'm showing you, they are not very precise, especially for float and double. They are just basically, approximated range. And then, that is more than sufficient. So moral of the story is, when we are dealing with float, double and long double, really we should not bother about the range. Okay. And when we are dealing with especially in character and int, and especially on the sys platforms where int consumes 2 bytes, so we need to be a bit careful, because these ranges, every range is meant for giving a wraparound effect. Wraparound का मतलब है कि 32767 के बाद में जो number आता है, it is minus 32768. If I'm right now talking about this integer range, देखिए, so what is the range? एक extreme पे we have minus 32768, and the other extreme being 32767. And if I step ahead of 32767, ek kadam aage, if I add 1 to it, what I encounter is minus 32768, because it is a wraparound. And if I step behind minus 32768, which is the smallest possible number what we can represent by using an int on a 2-byte representation platform, so ek kadam piche, one step behind, what I encounter is 32767. So you need to be careful. Okay, this is something about and data type. And I wish, I appeal to you all, if you have any questions, you keep posting your questions on a chat bot, and then we will definitely, if it is basically in line with the current discussion, we'll try to address them to some extent immediately. Otherwise, given a guarantee, is all the queries will be tackled at the end. And if not directly reaching to you, I take the responsibility of reaching to you in an offline manner by sending you the mail, and I'll be reaching to you guys. Don't worry. So going ahead now, coming to an operators, my dear friends, again, there is, I feel, especially for you guys having done so much of an things on C programming language, I'll not be spending too much of my time on the operators. And everyone knows that an operator in an expressions are evaluated as per their precedence, priority, level of importance. So if we have an expression, obviously while solving the expression and while evaluating an expression, the operator which is having the highest precedence among those which are available in the expression, they need immediate attention and more immediate attention as compared to rest of them. And in the order of precedence, we need to evaluate them. And then, needless to tell you that we can overrule this priority and precedence of an operator by using an parenthesis and bracket. So bracket basically is something which we should salute right at the top and at the beginning. So Bodomus, typically speaking. Now, among the operators with equal precedence, if we have more than one operators at par operators, their precedence happens to be same, priority level happens to be same, then the order is decided by the associativity. So the associativity will be telling us whether in an expression, given expression, we should move from left to right or right to left. And during this journey of left to right or right to left, whichever operator among at-par operators we encounter first should be attended first. So I believe you people knows. So now coming to the frequently required operations. So we have especially when it comes to an arithmetic category. So we have division, which is slash operator, and then we know that okay, when we uses this along with an integer, so the result will be integer. So int by int is integer. So 7/2 obviously okay will be 3 and not 3.5. Okay, so int by int is int, and it is not a rule really speaking. It is because of okay implicit conversion. There is something called as an type conversion. So there is something called as an implicit conversion. I believe you know. Automatically the conversion takes place, and when implicit conversion is happening, what is a simple thing what we should remember and understand? Out of the two operands, for example, division की अगर बात होती है, if we are right now talking about a division, so division operator is a binary operator. उसके left hand side में you will find one operand and right hand side operand. So it requires two operands obviously. Okay, so it is a binary operator. So in this, if the left hand side and right hand side का type happens to be different, अगर अलग अलग type के float and integer combination है, so the type which offers a wider precedence always will dominate, and internally the other operator also will get upgraded, promoted to this data type, the one which is offering a wider range. So now if both the operands are of same type, no such implicit conversion is required. Very simple. So int by int is integer. So int by 10 agar karte, so it is used to, and okay, you have done a lot of this, I know. It is used to scrap and remove the last digit of the left hand side operand. And where you have used this, so write a program to find the sum of digits. So what we do is that we obtain a digit and we add it and we slash it, we scrap it, we remove it. So removal ke liye you have done okay slash, and where you have used Armstrong number, where you have used to obtain the reverse of a number. So many times I believe you have utilized this slash 10 wala effect. Similarly, we have a modulus operator, which is a remainder operator, mod 10, which is used to grab the last digit of a left hand side operand. So it is grab. So x is agar 123, if we have x 123, and if I take x mod 10, what I get is last digit. And if I go for x slash 10, what I get is 12, because 3 will get removed. Then similarly, the utility, if I'm required to comment on the utility of this modulus operator, so it is very commonly used to test the divisibility and to test whether something is factor of something or not. So if we find that a modulus b is matching with 0, so we can immediately infer and draw the conclusion that a is divisible by b, or we can also say that b is a factor of a. Very simple. So this is something about an arithmetic operator. We have a ternary operator. Why it is called as a ternary operator? Because it uses three operands. So we have an expression 1 and we have an expression. So this a is this b greater than c. Sorry, b greater than c. Whatever comes prior to question mark is your expression 1, and what sits in between question mark and colon is expression 2. And what follows this colon is expression 3. So 3 operands, so it is ternary operator, and it is also called as an conditional operator. So it checks expression 1, and if the expression 1 is true, it uses expression 2. It settles down with expression 2. Otherwise, it settles down with expression 3. So in this case, especially talking about this, in this case, if you look at b greater than c, agar b greater than c is greater, if b is greater than c, then the value of b will get assigned to a, otherwise the value of c will get assigned to c. So this again very useful, sometimes we can use, and then we always can have a alternative to this of we writing down if else statement. So that is there. If you're comfortable with if else, go for if else. If you want to cut down and the length, and you believe in concise way of expression, so you can make use of this. So similarly, we have a logical operators, we have a logical and, we have a logical or, double vertical bar, logical or, double and, logical and not. This is a unary operator, logical not. So it is not of true is false, not of false is true. And stories, everything should be true for me to say true, and or is at least one should be true for me to say true. So there is no point for me to show you the truth table and again extend the discussion. I assume that you people guys are okay with this. Going ahead, when we have an bitwise operators, okay, and bitwise operators obviously meant for dealing with the bits, performing operations on the bits of the operands, and these bitwise operators only can be used along with int and character, my dear friend. The utility of the bitwise operators is not extended to floating point, means real values ke saath, along with real values we cannot make use of this. Okay? You cannot use this along with float or double or long double to say very precisely. Okay, so you can use it along with int, you can use it along with character, you can use this along with the qualified int and character, unsigned char, signed char, unsigned int, long int, short int, signed int, and so on and so forth. Okay, and when it comes to right shift, the purpose of right shift is to shift the bits of the left hand side operand to the right by specified number of positions. So अगर मैंने a right shift operator n लिखा है, if you look at this way of expression, please look at this way of expression, a right shift operator and n, the meaning of this is I intend to shift the bits of a to the right by n bit positions, and then this mathematically speaking can be regarded as equivalent to a divided by 2 raised to n. So a divided by 2 raised to n, this is an equivalence. And same story with the left shift. So left shift may uh, we intend, if I'm writing down, okay, a left shift operator n, if I look at this way of expression, so obviously we plan to shift the bits of a to the left by n bit positions, and mathematically speaking the equivalence is a multiplied by 2 raised to n. One more thing I would like to tell you, my dear friend, if I am trying to shift the bits to the left hand side, so it is but obvious. Okay, please try to visualize the scenario. I am trying to shift these bits. Okay, let us assume that the one which is I'm highlighting right now, this portion, I'm trying to shift to the left by 3 positions. So I will only highlight these 3 bits, okay, these 3 positions. So what will happen if we are trying to push this bit stream in the left hand side by 3 positions? These 3 leftmost bits, the most significant bits, will fall down, but obvious. And what will happen? The 4th bit from the left hand side will occupy the leftmost position, and eventually every bit will be getting shifted to the left hand side by 3 positions. And what is the net effect of this? You will find that 3 vacancies will get created in the right hand side, because okay, we are shifting bits to the left by 3 positions, so obviously 3 bits will get 3 vacancies will occupy in the right hand side, and these 3 vacancies will be filled by 0. Again, I'm telling you, in the left shift, the vacancies which gets created in the right hand side will be filled by 0. They will be padded by 0. Now, same is not the story when it comes to the right shift. Now, if I'm trying to apply the right shift effect, and if I'm trying to push these bits in the right hand side by say 3 bit positions, what will happen? The 3 bits, the 3 rightmost bits, those which right now I have highlighted, will fall down. Now falling down is an obviously the analogy. Falling down is we lose upon those 3 bits, and then what will happen? The 3 vacancies will emerge from the right hands, from the left hand side, sorry, because the rightmost bits, the least significant bits will fall down, and from the most significant side, from the left hand side, 3 vacancies will emerge, will appear. And most important thing, Please listen carefully. These vacancies now will get filled by the signed bit. So if the signed bit is 0, saying that the number is originally non-negative, it is positive number, the three vacancies emerged from the left hand side will be padded with, will be filled with 0. But had it been a case, if we are dealing with some negative number, let us look at this. Please look at this, okay? The last row of this. Now, if you look at the sign bit, the black one, okay, the upper part, not the lower one. If you look at this, so this the sign bit, this column is sign bit, the leftmost bit is always sign bit. अगर sign bit 1 है तो इसका मतलब negative number है, okay, the number is negative. If it is 1, and then if we are shifting the bits to the right by n positions, so n vacancies will appear from the left hand side, and these n vacancies will get occupied by obviously, okay, the sign bit, which in this case number negative अगर है तो it will be getting occupied by the one bit 1. So now coming back to this, the bitwise operators and or XOR ones complement, these are some bitwise operators, and I would like to, okay, give an illustration. So let us assume that we have two numbers, A is 53 and B is 88. And my dear friend, okay, this we are talking about a bitwise operator, so obviously we need to visualize this in a form of a binary number. So 53 being a positive number, uska bit the binary equivalent is this. So it's but obvious, okay, all bits will be set to 0 except 32, 16, 48 हो गया, 48 plus 4 is 52, 52 plus 1 is 53. तो इनका contribution आता है, बाकी कोई weightages का contribution नहीं आता है. I know that, okay, is you are aware of this. The rightmost bit, the least significant bit का weightage and power is 2 raised to 0, तो 1 है. दूसरे bit का second from the right का, second from the most significant side का, it is 2 raised to 1, so it is 2, and then you need to keep doubling. Okay, this is something what we know about an binary number system. So now coming to an 88 number, so 88 में there is a scope for 64 to contribute. तो बाकी सारे numbers मैंने 0 करवा दिए. 128 के लिए भी there is no space. 88 cannot accommodate 128. This is one way of, okay, settling down with the binary number. So 64 can, there is a space, so 88 can accommodate 64. So I set this to 1, and now I will subtract 64 from 88. So how much is left, my dear friend? 22 is left. So there is now no scope left for 32. 32 contribute because 22 बचा है. 16 के लिए जगह है, 6 बचा. एक मिनट. So 64 and 32 के लिए जगह नहीं है, 22 बचा है. 16 कंट्रीब्यूट करेगा तो ऑब्वियसली, ओके, 22 में से 8 बचा है, और 8 कंट्रीब्यूट करेगा तो कुछ भी बचा नहीं है, तो इट इज 10111000. सो दिस इज हाउ वी राइट डाउन the binary equivalent of 88. Otherwise, you have a very standard way of doing this. You keep dividing the given decimal number by 2, and you keep recording the remainder, and you keep doing this till the quotient doesn't settle down with less than 2, and then whatever remainders you have obtained, you need to express them in a bottom-up manner. So I'll not be, okay, taking you to that process. So now coming to an bitwise AND, I'm applying now bitwise AND. Single AND is a bitwise AND, and double AND basically, okay, is logical AND. So the beauty of this is same operator sometimes, okay, play a different role depending upon the context of its usage. So if I'm using AND, and if this AND is using is used along with two operands, so it is a bitwise AND. और अगर मैंने सिर्फ AND B लिखा होता तो यूनरी ऑपरेटर हो गया. AND B का मतलब चेंज हो जाएगा, and then it will be playing a role of an address operator. So sometimes this is called as an overloading कहा जाता है. It carries multiple meanings. Okay, you will come across this in Java and C++. So not spending too much of a time on this. So C is equal to A and B. Bitwise ending की बात हो रही है, तो corresponding bits के बीच में ending हो रहा है, तो 1 0 becomes 0, 0 0 remains 0, 1 0 0 है, और हमें पता है, okay, दोनों भी bits 1 चाहिए for V to settle down with 1. Otherwise, even if we have single 0, the result will be 0. So we get everything 0 except this combination. So if you look at the decimal equivalent of this, 16 is 1, baki sab 0 hai. So what we get by doing this is C ka value is set to 16. Okay, C ka value is set to 16. And one more thing, my dear friend, if had it been a case, if I write down double and, याद रखना है, double and, अगर if I'm okay for visualization, अगर मैंने ऐसा लिखा होता, if I write it like this, just wait. If I write it like this, A and B. So what I'm right now trying to tell you is that if I write like this, A double and B, तो double and का मतलब logical होता है, logical and, और logical and का result एक तो true होता है या तो false होता है, 1 0, बाकी कुछ नहीं है. But then when we play with the bitwise ending, तो bitwise ending का result true false कभी नहीं होता. It is always a number. It is a number what we get by doing this. And that is what I am right now showing you. So C is equal to A and B. अगर मैं करता हूँ तो what I get is 16. Similarly, now taking you ORing करते हैं तो ORing में even if we have one bit as 1 logical high, तो result will be 1. So green and pink combination देखना है तो 1 0 is 1, 0 0 is 0, 1 0 now becomes 1. Even if we have a single one, we'll be getting 1, and so on and so forth. So if we do the bitwise ORing अगर करते हैं तो the binary number what we obtain by taking a bitwise ORing in between A and B is something like this, and uska decimal equivalent obviously happens to be 64 plus 32 plus 16 plus 8 plus 4 plus 1, which comes to 125. Same thing for this caret symbol, raise than symbol. This is not a power operator. This raise than is an XOR operator. और XOR में क्या होता है कि XOR का result is 1 if we are dealing with the dissimilar bits, and XOR का result will be 0 if we are dealing with the similar bits. So 0 1 या 1 0, these two are dissimilar combinations. So what we get by doing this is 1, and XOR अगर 0 0 का XOR की बात होती है या 1 1 के XOR की बात होती है तो what we get by doing this is 0. Similar bits 0, dissimilar bits 1. So now coming to an XOR, so 1 0 is 1, 0 0 is similar, so we get 0. Look at this second last row. Now green and second last row should be your focus, okay, and what you should be looking at. So this green is the first two rows and the second last row. So 1 0 dissimilar है तो यहाँ 1 है, 0 1 dissimilar है तो 1 है, 1 1 similar है तो 0, and so on and so forth. So what we get by doing this is XOR operation, और इसका decimal equivalent is 109. And ones complement अगर मैं A का लेता हूँ, ones complement of A is जहाँ 0 है वहाँ 1 बनाइए, and wherever you have 1, you just change it to 0. So 1 gets inverted to 0 and 0 gets inverted to 1. So यहाँ 1 है तो what I get is 0. यहाँ 0 है तो what I get is 1, and so on and so forth. Now by doing ones complement, if you look at the sign bit, now sign bit is 1. Sign bit 1 का मतलब है the number is negative. And number अगर negative है तो for you to find out exactly the magnitude of this number, तो आपको क्या करना पड़ेगा कि you need to understand that कि अरे ये तो number being negative, this internally is recorded by using 2's complement representation. So if you are interested in knowing the magnitude part of this, so you take a 2's complement of this. So what I'm doing is that I'm taking a 2's complement. Let us do this together. Now look at this, my dear friend. 2's complement के लिए I will start a journey from right hand side, and I intend to move in the left hand side, right to left kind of a journey I'm talking about, and I will keep copying the bits as it is. 0 को copy किया, I am copying 1 as it is, and I will keep doing this as long as I'm not coming across the very first one. So this being a very first one, I stop this process, and thereafter now for rest of the bits what I do is that I invert and then I copy. So now when I'm copying down 0, it becomes 1, 1 becomes 0, 0 को copy किया 1, 0 को copy किया 1, and ये सारे जो बाकी के 1 है, obviously they will be converted into 0 for me to find out a magnitude. Now if you just look at the last row, absolutely the one which is in red color, very close to red, so you'll find that what is the magnitude? There is a bit set for 32, there is a bit set for 16. 16 वाला column जो है, ये 1 का weightage is 16. It is 2 raised to obviously 4. So 8 is 0 and 4 is 1 and this is 1. So it is 32 plus 16 is 48. 48 plus 4 is 52. 52 plus 2 is 54. So what I get is seek actual value, which if at all you try to printf this, you will get minus 54. Now this is a 54 is a magnitude, and y minus because sign bit 1 है, और sign bit 1 है इसलिए तो उस complement में record हो चुका है. More about printf and scanf. So scanf हमें पता है, okay, the most versatile function when it comes to taking an input from a console. You want user to enter through keyboards, values through input through keyboard. Obviously, okay, the most versatile happens to be scanf. Why I'm calling it as a versatile? Because it is capable of dealing with all data types. Okay, so integer को input करवाना है तो हमारे पास एक conversion character है, format specifier है %d decimal integer के लिए, and you guys knows this. So float की बात चलती है तो %f कहिए, डबल की बात चलती है तो परसेंटेज ऑब्वियसली ओके स्मॉल lf कहिए, कैरेक्टर की बात होती है तो परसेंटेज c है, स्ट्रिंग के लिए परसेंटेज s है, एंड लॉट मेनी आर देयर. परसेंटेज u स्टैंड फॉर अनसाइंड इंटीजर, परसेंटेज ul स्टैंड्स फॉर अनसाइंड लॉन्ग, percentage x stand for hexadecimal integer number, percentage o stand for octal integer number. Unfortunately, we don't have okay any provision made for binary. You cannot directly accept binary number. Probably okay the stream becomes too lengthy. Okay, so percentage b doesn't mean it doesn't mean that we are trying to make use of a binary. Okay, my dear friends, so be aware of this. So same is the story. Now one more important thing about an scanf, okay, what I'm trying to tell you is that the function definitely does its job. It obviously accepts all the values what we intend, depending upon how many format specifiers we have specified there. But in turn, it also okay sends back, it returns count of number of values it has read. So if it has accepted, it has received 3 values, so the function returns 3, saying that boss मैंने 3 values read किया है, something like that. And printf again is a very versatile function, and it is meant for displaying the values of all types. So similarly, it not only displays, but then okay, in turn it returns something for we to understand. It returns count of number of characters it has displayed, and the illustration is there. Example के लिए x, y, c की अगर ये if I declare these 3 variables as integer type, and if I write down, so I'm just trying to do 2 things. Okay, please look at this. I'm saying number of values read, and I'm just okay. I'm wondering, okay, how many values my scanf is reading actually. I'm just wondering about this. So I want to know how many values scanf has obtained. So I will use %d, and the parameter here is scanf function itself. So scanf %d, and I'm using only x and y. So this scanf is made responsible for reading 2 integer type of decimal integer type of values, and decimal number system obviously %d, and the first value will get assigned to x and second value will get assigned to y. Scanf definitely will do the job, and in turn will return 2, saying that if at all the attempt goes successful, the scanf says I have read 2 values, and this 2 becomes basically okay the value what your printf is supposed to display. Okay, is well and good. So if I assign the result of printf to C, in turn what printf will do, printf will give back the value which says how many characters printf has displayed on a screen. So now if you count, okay, my dear friend, if you count from this capital N, so you'll find this. So this is 1 and 2, and this dot is 3, space is 4, 5, 6, spaces again 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and finally this 2 is 20. So now what printf has displayed on a screen actually happens to be 20 characters, and that is the reason the printf returns 20, and that's the reason C का value becomes 20, and that is the reason printf second printf की मैं अगर बात करूँ तो what it displays is basically okay 20. Are you okay with this? So going ahead, more of an console input output function. So we have some functions. There are lot many, really speaking. There are lot many. but then to just comment on few of them, what C offers to us. So we have one function getChar, a function which is only and only meant for reading and inputting single character. Okay, it returns that character. So the way I'm showing you. Okay, so if there is a character type of variable I've declared, and if I write down ch is equal to getChar, so getChar reads one single character and returns that character, which obviously will get assigned to this ch. So then we have the siblings available, those which are basically meant for doing the similar type of job. We have an getch and we have an getche, and this getch and getche may not be working on all of the platforms, especially when it comes to Linux. Probably this getch and getche may not work because we don't have a console input output.h there. So clear screen and blah blah, all those functions whose prototype happens to be in conio.h. Conio.h जिसके लिए हम लोग include करते हैं. And I believe if you just talk about in general the experience, most of the time frequently we include this conio.h when we intend to make use of two functions. One is clear screen, CLRSCR, I assume, and then at the end there is a practice of writing down getch. Okay, so these are the two functions normally which have forced you to include conio.h. Otherwise, if you don't plan to clear the screen and get ch at the end, you need not include this conio.h. Now, why there are two available for the purpose? The reason is that this getChar comes with one limitation, and the limitation is that for we to enter the character, we need to go through two keystrokes. अगर मुझे capital A enter करना है, if I want capital A to be inputted, so I need to first hit capital A wala key, and this input will not be buffered, will not be provided, will not be accepted as long as I am not hitting the enter key. What I'm trying to tell you is that for entering a single character, we need to go through two keystrokes. दो keystroke की जरूरत पड़ती है. So someone may feel that यार why two keystrokes? Okay, why not only single keystroke? जो character को input करना है, बस I should press only that character and my job should get over. So for that purpose, we have an getch and getche. And what is the difference in between getch and getche? In getch, what we press, what we intend to input, we press that key, and the key, the character is not visible on a screen. And when getch की बात करते तो E stand for an echo. You can take it in that spirit. We get an echo, okay, on the screen. So what we press also appears on a screen. Why we need these siblings? Why we need get character? Can't we survive by using scanf %c and ch? Can scanf also can accept the character? So why we need these special functions? So scanf ka especially while dealing with characters and string. After all, string is nothing but a sequence of character. There is one limitation. The scanf cannot read white space characters. Blank आ जाता है, या \n है, या \t है. ये सारे जो white space characters है, इनको scanf read नहीं कर सकता है. Okay, वो stop हो जाता है. So that is the reason अगर आपको ये चाहिए, if you intend to also ensure that white space characters also should be inputted, so you have other option made available for the purpose. Otherwise, we can make use of a scanf. Similarly, my dear friend, for an output, we have an putChar. PutChar, get a character and put a character kind of a philosophy. So putChar is a function, output function, it displays a character. But then, there is no need for you to make use of this, because printf also can suffice. Printf doesn't have any limitation. So even printf %c will be displaying a character, and printf also can display an white space character. So there is no as such a need to make use of an put character. But then sometimes we may require getChar or getch, especially when we intend to accept one blank space character, white space character. Now, after having discussed this much, very simple task for you. I don't want you to immediately start playing with this, but I want logically you to spend a time on this. It's advisable. थोड़ा सा सोचिए इस पे. It's advisable for you to be with me. And very simple task, my dear friend. A 4-digit hexadecimal number is provided to you. How we express a hexadecimal number in C language? A number needs to be preceded by 0x. तो मैंने नीचे लिखा है hint A का declaration 0x मैंने ऐसा किया. So what we need to do is that a number आने के बाद में we need to write down in C program to determine whether the first, third, eighth and ninth bit are zero or not. अगर वो जीरो है या नहीं है. So if it is not zero, you need to display zero, saying that it is not zero. And if it is zero, so your answer is yes, it is zero. So for true, you need to display one, and for false, that is no, you need to display zero. ऐसा करना है. And similarly, you need to do the same activity for 4th, 5th, and 11th bit. But then instead of zero, your focus should be one. तो वहां अगर 1 दिखाई देता है तो you need to display 1, and अगर 0 दिखाई देता है तो you need to display 0. So what you are supposed to do is that, in fact, my dear friend, when it comes to building up a logic and framing a logic, we should not impose any restriction. Okay, the way you think and the way it goes, you should first try to logically frame the given problem, try to address the problem, implement it, and once you are happy with that, then comes the optimization and refinement. So पहले तो solution चाहिए और उसके बाद में refined solution चाहिए. So first try to settle down with the solution, develop this habit. So the hint is given, and I will just give you a very simple way of doing this. So पहला अगर मेरा focus very first bit, I mean the one which comes from the right hand side, the least significant bit, the right hand side bit. So yeah, this is a number. The number is expressed obviously in form of an binary, and this is a negative number, because a अगर मैं set करता हूँ तो a leftmost bit 1 हो जाएगा, तो उसका decimal equivalent find out करेंगे तो number is negative. Let it be, sign bit is 1. So this is how it will look like, because converting a hexadecimal number into an equivalent binary is a very simple story. For every single digit hexadecimal digit, you need to settle down with a chunk of 4-bit binary bits. So B का binary equivalent is 1011. Similarly 1 का binary equivalent is ये pink color में जो दिखाई देता है 0001. 0 की अगर मैं बात करूँ ये green color में, उसका binary equivalent is 0000. 4 bit से use करना है. और अगर a की बात करूँ, a का मतलब 10 होता है, तो it is 1010. This is how we write down basically the binary equivalent. So now my focus is on the rightmost bit, bit number 1. So what I do is that b का value 00, बाकी सब कुछ 0, लेकिन सिर्फ rightmost bit को मैंने 1 कर दिया, because उस पे मेरा focus है. And what I do is that I take an bitwise ANDing. My dear friend, ANDing is a very useful, bitwise ANDing is a useful utility, a useful operator, and it is used for something called as a masking purpose. Masking का मतलब होता है all those bits which right now you are not interested in, you mask them off. So you convert them to 0, and only those bits what right now you are focusing on, you don't touch them. So you want to retain them as it is. So those which are required to be retained as it is should be bitwise ANDed with 1, and those which you are not at all interested and you want to hide them, mask them off, so you need to do the bitwise ANDing with 0, and that is what I am doing. So my focus is only on the rightmost bit, and rest of the bits are set to 0. And what I do is that I take an bitwise ANDing. Bitwise ANDing लेने के बाद में मुझे क्या मिला 111. इसका मतलब है the very first bit in the original number is 1. So I can say that ये 0 नहीं है. तो 0 नहीं है तो I will display obviously 0 there. समझा ये? Because 0 अगर होता तो मुझे हाँ कहना है, 1 कहना है for 0. Bit number 1, 3, 8 and 9 focuses on 0. Bit number 4, 5, 11 focuses on obviously 1s. So same story I can do. Now when I change my focus to obviously if I change a focus, my focus to the third bit which I am right now highlighted. ये third bit देखिए. So third bit पे focus है, तो I am only interested right now in looking at bit number 3, and rest of the bits I am not at all interested in. So only third bit is set to 1 and rest bits will be set to 0 in B. Ending के लिए B is basically okay, masking के लिए mask है मेरा, तो B please regard B as an mask. So बाकी मैंने सब 0 0 0 कर दिया एंड 3 बिट नंबर 3 के जगह 1 लिखा और बाकी सब 0. तो मास्किंग अगर अगर इसका बाइनरी इक्विवेलेंट मैं देखूं तो बाइनरी सॉरी डेसिमल इक्विवेलेंट, so decimal equivalent is 4 because 0 1 0 0 is obviously 4, binary में 4 है. तो b का value I'm setting this value to 4, obviously okay is it should be 0x04, जैसा यहाँ भी it should be 0x001. so इसको 0x004 मैंने किया and then I take an bitwise ANDing, and bitwise ANDing लेने के बाद में क्या होगा कि this is 0 and this is 1, so bitwise ANDing 0. So I'll say bit number 3 पे original number जो है a, bit number 3 is 0. So in my program I will try to display 1 there. This is a very simple task. I wish you will be trying. And my dear friend, there is another way of doing this. The another way of doing this is same is the story, same remains the task. What I will do is that I can also make use of a right shift operator. What I will do is that I will keep my eye on the vigilance, my eye, my camera, the vigilance, my focus will be only on the rightmost bit. And what I will do, rightmost bit पे मेरी नजर है, rightmost bit अगर 1 है तो 0 के लिए I will display 0 and 1 के लिए I will display 1, something like that. Okay, are you getting this? So rightmost bit पे मेरा focus है. What I'll do is that यहाँ 1 दिखाई देता है तो bitwise 1 I will do the bitwise operation. यहाँ मेरा mask I will okay is a static mask. My mask will now not change depending upon the bit right now I'm focusing upon. तो मैं उसको 0001 मैं कर दूंगा. So मेरा क्योंकि focus bit number 1 पे ही है तो मेरा mask अभी static है, freeze कर दिया मैंने mask को. तो bitwise तो मुझे मैंने करना है, I need to always do the bitwise ANDing with 0001. That's all. So मैं bitwise ANDing करूंगा. Are you okay with this? Then what I will do, I will shift my number. The number will be shifted to the right by 1 position. तो क्या हो जाएगा? The second bit, originally the second bit from right now will get shifted to the rightmost position. Then again I will do the bitwise ANDing with 1. Then again I will shift this by 1 position. So original third जो था from right, जो third bit था जो अभी second position पे आ चुका है, now will get shifted to the rightmost position, and I will keep doing this. And I wish I'll be showing you the program for this. This gives me an opportunity. So this is one simple program. Okay, I can show you both the versions, but then the first one appears to be slightly very simple. So this part is, please don't look at this part. This 8 minute. I am assuming that guys, this is now visible to you. This is visible to you. So what I'm doing is that I'm putting this in a comment. So let us assume that this is a number what we already have discussed about, and R basically stands for result. I am using for just okay, keep doing this again and again, repetition. Now I enjoy the liberty and I enjoy the privilege of using for loop. Even in today's session we still have not really reached to the for loop, because I know that okay, it's not to underestimate your abilities and student power. I know that you know this for loop. So this for loop is meant for getting repeated how many times, my dear friend? It is meant for getting repeated 11 times. So what I'm doing basically okay, bitwise ANDing with what? I'm doing bitwise ANDing with 1, right? And whatever is the number. So if the result, अगर bitwise ANDing का result 1 है, तो इसका मतलब result 1 है. 0 है, तो rightmost bit position पे 0 बैठा है. Again, I'll repeat. I'll put a comment. So if I'll say if R is matching with 0, what it implies? It implies rightmost bit is what is 0, else rightmost bit is 1. So अगर इसका result 0 होता है, so what I'm doing is that depending upon right now which iteration is going on, when I is 1, इसका मतलब right now I am talking about bit number 1. If I becomes 2, I'm talking about bit number 2, but I'm not interested in bit number 2. Our focus is on bit number 1, our focus is on bit number 3, our focus is on bit number 8, bit number 9, and our focus for these many bits 1 3 5 1 3 8 9 के लिए हमारा focus 0 पे है. वहाँ 0, we are eager to know whether 0 is there or not, and 5 4 5 and 11 our focus is on, okay, is we are just eager to know whether there is actually bit is 1 or not, okay, logical high hai ya nahi hai. So 11 bit tak hi jana, isliye I'm making my for loop to repeat from 1 to 11, and every time what I'm doing, I'm taking a bitwise ending with 1, and after, okay, is getting this result, agar result 0 hai to rightmost position pe bit number 1 position पे 0 बैठा है, otherwise 1 बैठा है. And what I do is that depending upon I, switch case use कर रहा हूँ, I का value 1 है, इसका मतलब bit position 1 की बात हो रही है, तो case number 1 में चला जाएगा. And what I'm doing is that I am displaying the value of R, but by taking a obviously, okay, not of R की बात कर रहा हूँ. Look at this, my dear friend. It is not of R. इसका मतलब है कि why not of R? Because R का result अगर 0 है, तो for 1 3 8 9 वहां 0 है, तो हमें हाँ कहना है. We need to say yes, we need to say true. So if R is 0, it means that rightmost bit position is 0, so we need to say 1. We need to say, so that is the reason I'm doing not of R. And same is the story, अगर वहां 1 होता है तो 4 5 11 के लिए अपना focus is on 1, so I'm just displaying R का value as it is, and that is how it goes. So after dealing with 1 bit, then what I do is that I'm shifting n ka value to the right by 1 position. So what happens in general, if you look at this, पहला iteration I का value 1 है, we take a bitwise ending with 1, value of I is 1, case number 1 plays a role, and then, okay, rightmost bit पे whatever happens to be the bit 0 or 1, we display accordingly. Break will throw the control outside. Now we are about to move to the next immediate bit. I shift n ka value to the right by 1 position. So second from the right becomes rightmost, and then I go back, but value of I becomes 2, and then we are not interested in, okay, bit number 2, the bit available at position number 2. So I have not written any case for that. So nothing will happen. The value of n will get shifted to the right by 1 more position. So the second from the right becomes rightmost. But now, okay, beware of one fact. Right now, the second from right originally was third from right. So third bit abhi rightmost position pe aa chuka hai, and we keep doing this again and again. So if you just if I compile this and if I run this program, what you get is the result. So bit number 1 के लिए you can just make a note of this. Bit number 1 के लिए हमने 0 बताया, and rest bit 3 4 5. Bit number 3, I'm again repeating, 1 3 8 9 0 पे फोकस है, तो 1 0 है, 3 1 है, इसका मतलब बिट पोजीशन 3 पे 0 बना है. बिट नंबर 8 पोजीशन पे देयर इज अ 0, बिट नंबर 9 पोजीशन पे देयर इज अ 0, इसलिए वी आर सेइंग 1 का मतलब हाँ. And bit number 4 पे there is a 1, bit number 5 पे there is 1, so we are saying yes, and bit number 11 there is 0, so we are saying 0. So you just look at this, and I will again, okay, show you going back to uh, what I can say, going back to this. Just wait, my dear friend. So okay, well and good. Not ready to get shifted anywhere. So oh ठीक है. So what I do is I'll take you here, the previous slide, and then now you can check. Now you can check. So if you look at this, at position number 1 we have 1 0 नहीं है इसलिए 0 डिस्प्ले किया था. एट पोजीशन नंबर 3 पे 0 है इसलिए हमने हाँ कहा था तो 1 डिस्प्ले किया था. एट पोजीशन नंबर 9 पे 0 इसलिए 1 डिस्प्ले किया था. एट पोजीशन नंबर 11 पे 0 है इसलिए 1 डिस्प्ले किया था. Am I right? And similarly at position number 4 पे 1 है इसलिए 1 डिस्प्ले किया. एट पोजीशन नंबर 4 पे 5 पे 1 डिस्प्ले किया था. एंड एट पोजीशन नंबर 9 पे we have obviously 0 इसलिए 0 डिस्प्ले किया था. Something like this. So I wish you will be trying this on your own. So my dear friend, to go ahead, take you ahead of this, going ahead, as we say that every accomplishment starts with the decision to try. So we believe in you guys, and we believe all the tasks what we are keeping in front of you, and all the tasks what you already have decided for yourself, you will be giving a try to that. And this is basically a link what you will get towards the end concluding part of the session. And I wish you will be trying this. They are simple, they are interesting, and if you have any queries regarding this quizzes, you will be updating me about that. All the best for this quiz, but then not for me to conclude, because still we have a time. And then the best part of this is if I can take you ahead, spending less time on some basic fundamentals, I get an opportunity to spend more of a time on functions and pointers and dynamic memory allocation. So I wish I'll be still I'll with your consent, and with your permission, I wish I will still continue, my dear friend. And so going ahead. So again, just realizing that after all these years, the world is still powered by C programming language, and we already have come across the evidences and the popularity index. Now, taking you to control statements, because everything what we have discussed, the basic fundamentals, they only are capable of supporting something called as an sequential programs, where every statement gets executed one after another. And if the life is sequential and is not ups and downs, we know that is probably it says that you have still not achieved anything much. So we want we believe in adventures, and the life should be thrilling. So life is full of ifs and buts, and they can be solved if we face them with the guts. And you people, you have those guts available with you. Coming to control statements, we can broadly classify the control statements into 3 categories. Selection is one category, loops and repetition is one category, and unconditional jump happens to be one category. And selection, we have if statement, we have if else statement, we have switch statement. Then in loops category, we have a while statement, we have for statement, we have do while statement. Unconditional jump is just it throws the control from one point to another without evaluating any condition. So we have a break, we have a continue, and we have a go to statement. And then is I personally believe that especially my interaction with those who are stalwarts in C programming, so they say that please just ignore go to. They say that uh, assume that go to as if go to statement, and this facility is not at all there in C programming language. So please don't use this. Okay, we heavily discourage the use of go to. Okay? Please don't use go to. So going ahead, coming to an if statement, and the simple philosophy of okay is if you call, you should rise back, and then if you fail, you give a try again. So if statement, and typically speaking about the syntax, if expression is true, then and then only the if part and if block is allowed to play a role. And if the expression is false, this statement, the block of if will not get an opportunity to play a role. So if x is greater than y, this blue color printf will play a role, and then the execution will proceed, and this printf in a black, that is star star star, will also play a role. If x is not greater than 5, then obviously the entry will not be given, and if block is will get skipped, and only this black color printf will be playing a role. And if we want more than one statements to be fitted inside an if block, everyone knows, so you need to obviously okay is now demark this block. Demarcation is required more than one if we plan to embed. So this demarcation is done by using opening curly brace and closing curly brace, as it is apparent, as you guys knows. So if we want more than one statements to be fitted, as it is there, printer print do chahiye mujhe, I want two, so I'm putting opening closing brace and closing curly brace. So if someone asks us how many are there sitting inside if block, so I'll say all those which are lying inside opening and uska companion closing brace. And if it is not there, only one single statement is regarded as a part of an if. So if expression is true, the block plays a role, otherwise the permission denied kind of thing. Going ahead, we have if else statement, very useful if you have a plan of doing something, if the expression is true, and doing other thing if the expression is false. So if it is true, I will do it, I will do this, and if it is not true, I will do that kind of an philosophy. So we have an if else available for the purpose. So if expression what we write down inside and parenthesis goes true, so if part will play a role, if block is allowed to play a role, and else block, the door of else block will remain closed and permission denied. And but if expression remains false, if it is false, then if block will not play a role. However, else block plays a role. And then after if playing a role or else playing a role, after this is done, the execution proceeds with rest of the program. Okay, so my dear friend, what I'm trying to tell you is that in a rarest rare possibility, sometimes okay, we have come across someone may they start regarding this if or if else as a loop, but then just okay, word of caution is that not required, but then still okay, word of caution is if is not loop, if else is not a loop, they are not meant for repetition, they are conditional statement, they are selection category. Okay, they do, and then they say please go ahead, they say control of the execution, you have played a role, and you please proceed with the rest of the program. So there is no coming back business available. So this is about an if and else. Now one way to get a better insight of if and else is okay, just trying to have a decision kind of a matrix. So if you look at this example and the decision matrix to the right hand side, you'll find that if we are wondering if when the statement s1 will get an opportunity to play a role, s1 ka execution kab hoga, when s1 will get executed. So it is very clear that for we to reach to S1, the if condition even should be true, then we are allowed to enter inside. What we encounter is another if else statement. This if statement needs to be true, then and then only okay, the S1 will get an opportunity to play a role and will get executed. So for S1, E1 should be true as well as E2 should be true, S1 will play a role. If E1 is true but E2 is false, then obviously S2 will play a role. Just look at this. E1 darwaja khul gaya, we enter inside, and if E2 is false, so permission denied inside if, but then eventually we enter inside the else of this if, and that is the reason S2 gets executed. However, if even itself is false, so will not get an opportunity to enter inside, directly will be thrown here, okay, in the else section, and S3 plays a role. So for S3 to play a role, even needs to be false. And my dear friend, okay, one more thing I would like to tell you. Great. I'm trying to tell you is that uh, if someone asks us, okay, what I'm trying to highlight is, someone asks us how many statements are sitting inside if, this if I'm talking about, this if, okay, the one which right now, ye if ki baat ho rahi hai. And then look at this, how many statements are sitting inside the very first if. So my answer to this should be only one single statement resides inside if. Why? Because if else is a single statement. If else, these are not two statements. If else is a single statement. So that is a reason, as there is only one single statement inside, I need not, okay, cover this, demark this by putting, okay, an opening and closing brace. But then I always recommend, and we recommend, okay, from, okay, all our team of C programming language from Vidyalankar Institute of Technology, our institution, we recommend, if you are feeling safe, if you are comfortable, okay, always showing the braces, curly and opening and closing braces, you show it, nothing wrong in that. But yaha iski jarurat nahi, because there is only one single statement sitting inside, okay, well and good. So if else is a single statement. And one more thing, agar jodi lagana, if we want to establish a pair formation, we need to do the pairing. So kabhi bhi na, else is regarded as getting paired with the nearest unpaired if. So ye else ka jodi, if I start moving upward, I have two ifs available. So this else will be connected with the nearest if. So iske sath uska jodi lagega. Are you okay with this? So yeah, this else is connected with this is what I mean to what I can say, tell you. This if is connected with this, okay, nearest one. Well and good. And then iski bari aati hai. Now if I'm talking about this else, so this else should be connected with, should be paired with the nearest, in the upward manner, in a backward manner, nearest unpaired if. So if I start going back upward, and then I will encounter this if, but then it is already paired, uska jodi ban chuka hai, jodi bana di hai, okay, Rab ne. So the only one which is left and nearest one is this if. So obviously, okay, this else is regarded as connected with the second else. And same thing, okay, same thing. So if I start with the innermost else, let's say with which, so I'll say it is with this. Are you getting this? इसका जोड़ी इसके साथ, और ये इसका भी जोड़ी हो गया, इसका भी जोड़ी हो गया, तो इसका जोड़ी is connected with this. So that is how the else will get paired with syntactically, or from compiler perspective will get paired with. So this is something about the decision matrix. The decision matrix and its useful utility. Now going ahead with, my dear friends, I'm not intentionally showing you any demonstration of if and if else program. Now, if at all, if I ask you, okay, just try to recollect all those programs where you have used heavily if else ladder embedded. So I know that in a no time you can obviously take out all those words from your ammunition. You can say that, okay, what you can recollect is quadratic equation, roots of quadratic equation, okay. What you can recollect is finding the largest or smallest among the three number. What you can recollect is given a percentage, finding out the corresponding grade. If percentage is greater than above A, the grade is O. Otherwise, the grade is A and E, say, and so on and so forth. So there are lot many programs you guys have done, and I believe you guys are very much comfortable with this. And with this assumption, I prefer not to show you any demonstration forcibly in front of you, but my dear friend, the option of you raising the query, be it as simple as possible, uh, nothing wrong. You just raise those queries, and then we will be reaching to you, okay, for all those nitty gritties. Okay, believe in us. Okay, we believe in a student centric environment. So going ahead with the second category, which is iteration, the loops, and then try until you succeed. Okay, a very old phrase, and this is what the loop is. So you need to keep doing and doing and doing the things as long as, okay, the goal is not reached and achieved. So we have three statements falling in this category. We have a while loop, we have a do while loop, and we have a for loop. The order doesn't matter. Whichever you people are comfortable with, you can use that. Okay, there is no as such hard and fast rule for which loop to use when. I believe it is left to an individual test and the affection and the choice. Okay, as long as it is serving the purpose. So coming to an while, so you have an while condition and statement, while being an loop. So what while says is that after you have done with my block, this statement is regarded as belonging to while block. So if the condition is true, you're allowed to enter inside, and you do everything, every step which is lying inside. Then you will come across the end of the loop, and end of the loop always says go back. End of the loop ka ek hi kaam hai, okay, is someone hereafter, okay, if someone asks us what end of the loop says, so you should say end of the loop always says go back. Go back is what end of the loop says. So the control is sent back for the next possible iteration, and then it's very true. The fact remains, the next iteration will happen or will not happen, depend upon the outcome of the loop condition. If the loop condition still is evaluated to true, you will get entry inside, and again the second iteration and second checker and second pass of the loop will take place, and again you are required to go back. And if the condition now, if it goes false, so then the permission denied. The moral of the story, which is applicable to each and every loop, as long as the loop condition is true, the subsequent iteration is allowed to happen. The next iteration will be happening. But if the loop condition becomes false, the permission will be denied. And now the loop will not iterate. And now the execution will proceed with rest of the program. And that is what, okay, basically, okay, is what I'm trying to tell you and show you. To the right hand side, there are few examples. Very simple for you. But then it is just an maybe an attempt from my side, okay, to brush up and for you to recollect all these beautiful and old memories, okay, of dealing with the while loop. So I ka value is set to 1, and the loop condition is as long as I is less than or equal to 3. The loop is meant for repeating. So jab tak I ka value is less than or equal to 3, the loop will keep repeating. There are two statements sitting inside an while loop, and it is in printf followed by plus plus I. So what happens is I is 1, I less than or equal to 3 is true. You are allowed to enter inside. What you come across is a printf. The printf will display the value of I, which is right now 1. Then plus plus I, a pre-increment obviously will increase the value of I by 1, becomes 2. Then what you come across is end of the loop, closing brace. And end of the loop says go back for my next possible iteration. The control goes back. With what value of I we are going back? We are going back with I as 2. So again the loop condition is tested because it is a kind of a gatekeeper. Says show me your ticket, and if your pass and ticket is satisfying the criteria, then and then only you are allowed to enter inside. Kind of a philosophy. So I ka value is 2, 2 less than equal to 3. So you get inside, and then the printf plays a role. The value of I will appear 2. I am not using backslash n. All the values will appear side by side with some gap in between, and then the value of I becomes 3, and this will keep on happening. So last value of I for which the permission will be given is 3. 3 appears. I ka value becomes 4. End of the loop says go back. With I as 4, we go back. And then 4 less than equal to 3 is false. The loop condition becomes false and says sorry, permission denied. And then, okay, the execution proceeds with the rest of the program. and printf, in which is black in color, will play a role, and then will display 3 stars, and the 3 stars appear. So this is how basically it goes. Same story we can write down. We can write down I plus plus in a printf. Now, how many statements are there inside while loop here? In the second example, there is only one printf, which is I plus plus. This is post increment. Post increment का मतलब है I का value पहले जो भी है, whichever is the value of I, will first get displayed, and then the value of I gets incremented. So where you find end of the loop? The end of the loop is printf, blue color वाला जो printf है. You find wherever it get, this semicolon is end of the loop. So it says go back. So after I becomes 2, it goes back, evaluates the loop condition, and ये चक्कर चलता रहेगा, and same will be the output. This is how basically the while loop iterates. I am not intentionally showing you the flowchart representation of this, and you can always revisit. Okay, there are ample of learning resources available, and the best opportunity for you is to interact. Rather, okay, it's an opportunity for all of us from my side, be it me, be it Mandar sir, be it Sanjeev Dvedi sir, be it Rugved Devdekar sir, be it Amit Nerurkar sir, Swapnil is there, Bhanu is there. So we as a team, we are eager to interact with you guys. Okay, so you please give us an opportunity, and done with the day, we will get a feeling. Okay, so going ahead now, my dear friend, the next loop which comes is an for loop, and we have these 3 expressions available. For loop ka typical syntax: expression 1, expression 2, expression 3, and the statement. So expression 1 is a initialization, expression 2 serves the purpose of loop condition, expression 3 is an update expression. And we know that, okay, expression 1 एक बार ही execute होता है because it does the initialization. It should not be regarded as a part of repetition. It plays a role only once, that too just at the beginning of a loop. But then for we to enter inside a loop, expression 2 is a deciding factor. If expression 2 is true, you get a permission to enter inside. If expression 2 becomes false, the permission denied kind of a thing. And after everything gets over, statement ho gaya khatam, pura if for block has played a role, end of the loop comes into the picture and says go back. In a going back journey, expression 3, which is meant for updates, which is meant for applying an updates, plays a role and performs the specified updates, and this will keep on happening. सबसे important thing is that if expression 2 is missing, expression 2 अगर नहीं है, so it should not be regarded as the syntax error. Rather, expression 2 unavailability says that it should be regarded as if the loop condition is always true. और always true का मतलब है your loop now, the door of the loop is open forever, and it is an forever invitation given to you. Okay, is you are always okay. We welcome you always, and uh, the loop will forever repeat. Obvious, we can have forcible termination by putting some if condition and then executing break. That option is always there. What right now I'm trying to tell you is that ये expression 2 यहाँ जहाँ cursor है, if expression 2 is missing, तो आप ऐसा समझिए, you please treat this as if expression 2 loop condition is true always, as and when you evaluate. And my dear friend, to the extreme, you can have a for loop even without all 3 expressions. So you can have a for loop looking something like this, very much possible. So you can have a for loop. Great. So I wish this is a for loop, right? Yeah. So you can have a for loop looking something like this also. This is absolutely a valid for loop. Now, why we'll be doing this is a different story. Okay, but for some reason, as per the your logic appeals to you. Okay, so this is fantastic. So this is a very much valid for loop. We don't have expression 1, we don't have expression 2, we don't have expression 3. Well and good, acceptable. Expression 2 missing, always true. Okay, so but the presence of these 2 semicolon needs to be there. So if I try to have a for loop like this, if without these 2 semicolon, then you are in a trouble, and the compiler basically will raise an objection. This is syntax error. This is not as per what is recommended and what is expected from my side. So even if you are trying to miss some of the expression, not to specify them, these two semicolons are required. Okay, something like that. So going ahead from this point, and to the right hand side, there are some examples. Now, if someone asks us, okay, how many times the for loop will repeat? I'll say the for loop will repeat 3 times. From 1, the journey begins, and the for loop will take I ka value up to 3. And during every checker and pass, the value of I will get incremented by 1, and blah blah, and the output will appear something like this. Same thing, this is for we to understand. You can have n number of initializations as a part of expression 1. You can have n number of modification attempts as a part of your expression 3. So if someone asks us, okay, second example, look at this. कितने initialization के attempts हो रहे हैं? How many initialization attempts you find happening as a part of expression 1? So our answer should be 2. There are 2 initialization attempts. We are setting a value of I as 1, and we are setting a value of j as 5. So initially I is 1 and j is 5. And if someone asks us, boss, how many update attempts you find as a part of an for loop? So you'll say, okay, well and good, there are 2 update attempts. The first one is the value of I is attempted to increase by 1, and we attempt to decrease the value of j by 1 during every iteration. And what is the loop condition? Right now we are keeping a vigilance only on I. Well and good. So as long as I is less than or equal to 4, the loop should iterate, and the pass should go on and go on. So I initially is 1 and j is 5. 1 less than equal to 4, the entry is given. What appears is 1 and 5. Second iteration, I becomes 2, j becomes 4. Second iteration is permitted because 2 less than equal to 4. So what appears on a screen is 2 and 4. Third iteration के लिए I का value 3, j का value 3. 3 appears on a screen. The next iteration, I का value becomes 4, j becomes 2. 4 less than equal to 4 is true. The entry is given. 4 and 2 appears on a screen. Then the loop ends, and end of the loop says go back. And in a going back journey, the modification attempt plays a role. The value of I becomes 5 and the value of j becomes 1. But now when the value of I becomes 5, when the loop condition is evaluated, 5 less than equal to 4 becomes false, and then it says, sorry my dear, permission denied. And that is the reason the control comes out, and then we'll proceed with rest of the program. And well and good, what appears on the screen is three stars, something like that. I assume that you're okay with this. This is how a very short discussion about an for loop. And you have a nested for loop. In fact, you have a nested loop. A loop inside a loop is a nested loop. And nested loop का एक typical characteristic क्या होता है? किसने हमसे अगर पूछा तो nested loop का typical characteristic is for every single iteration of outer loop, inner loop iterates multiple times. So outer loop का एक चक्कर, one pass of outer loop, all the passes of inner loop. For every single pass of outer loop, inner loop completes all its passes. Is a very simple description of a nested loop. Nested loop you guys have used heavily. Why heavily I'm saying? Because whenever it comes to displaying and patterns, okay, and then I don't know, both of us, I mean, the faculty as well as students, they are to some extent fascinated by displaying the patterns, especially in the first year of engineering, and we spend considerable time there, right? So variety of patterns, and the patterns के लिए the best fit and the best suitable is nested for loop. So I don't want, my dear friend, again for you to go through that relishing experience of again dealing with the patterns, because I know that you can do it on your own, and if not, then we are always there ready to be your companion. Okay, so we enjoy that. So this is something about an for loop. Now there is one more which is left, and do while loop, and this brings back possibly the old memories to you. I assume a distinction and comparison in between while and do while, a typical University of Mumbai question. And do while iterates at least once, while may not iterate at all. And I will not talk about everything, because there is one reason for at least once characteristic of an do while. And many a times we believe in this philosophy, right? At least once, एक chance तो दो, बाद में next time अगर नहीं देखो मेरा performance और मत दो. So at least once, please check the eligibility next time. At least once you give me an opportunity. If this kind of a need arises, do while is the best suitable. So because do while is a exit control loop. उसका loop condition is tested at the exit point and not the entry point. So एक बार execution तो होना ही होना है. Next time whether it will happen or not, it all depends upon the outcome of loop condition. So these are some examples in front of you. I equal to 1 and एक बार execution होगा and I will get displayed and the value of I becomes 2. 2 less than equal to 3 is 2 and we go back and then again 2 will get displayed, 3 will get displayed and then value of I becomes 4. And when the value of I becomes 4, this while says loop condition becomes false and says don't go back, now proceed with rest of the program. This will be the output. This is normally a very common example we normally use this, okay, for just to show the distinction in between while and do while, and just to emphasize that while may not iterate at all and do while, irrespective of the loop condition we are imposing, iterates at least once. So I is set to 1 and you get an entry, value of I will appear on a screen, value of I becomes 2, and now the gatekeeper comes and loop condition says that boss, you show me your okay ticket. And this is not a very suitable example for theater and cinema hall, because you need to show your ticket at the entry point and not the exit point. Probably okay, in restaurant you're allowed to enter inside, have a food, but while coming back you need to show the ticket, that is you need to pay a bill, something like that, okay. So I greater than 2, which is 2 right now, 2 greater than 10 is false, so you're not allowed, the loop is not allowed to iterate, control comes out. So what happens is 1 and star. In case of while I is 1, the entry control loop 1 greater than 10 is absolutely false. So permission denied. So the loop will not iterate at all, rather will not get executed. And what appears on the screen is only 3 stars. So many a times what happens is that we need to deal with multiple options, okay, and the life is full of choices, we believe, and when you, at a time you need to deal with lot many choices, well and good, okay, is one statement what C offers to us is switch case statement. Yeah, sometimes it is also called as a switch statement, and you always can have an iska equivalent, an if else ladder kind of an equivalent of an switch, but sometimes for some situation using switch brings a simplicity, and as they say that okay, beauty lies in simplicity. So sometimes if switch appears to be best suitable, we'll use switch instead of using an alternative which comes in form of if else ladder. So this is an expression of okay, the syntax, which expression you need to write down a case and followed by a label and n number of statements followed by break and blah blah and followed by default statement, and break is optional. You can have a case block without a break. Break agar nahi hai, so it will not be an forcible break. This is an emergency break, because otherwise I prefer to call this break as an emergency exit. And I call this ये closing brace दिखाई दे रहा है. Please look at this closing brace of switch as a main exit. So if break is there, you are allowed to immediately, the control is allowed to immediately come out of this switch block. It is emergency exit. Otherwise, the execution will proceed till the main exit. ऐसा उसका मतलब होता है. And there are some restrictions. Expression should be integer type or character type. You don't enjoy the privilege of and liberty of using floating type, that is a real or double type of an values here in the expression, because expression ka final outcome needs to be integer or character constant and nothing else. Okay, so that is the reason the labels also should be integer number or character constants. So what happens is x mod 10 अगर मैं करता हूँ, so example के तौर पे x mod 10 किया तो obviously what we get hold of is a last digit of x. So we get a last digit, and last digit can be either 0, 1, 2 or up to 9. So if this last digit is matching with 0, the case 0, this block will play a role, because the value of expression should match with the case label for that case label to give us a permission to enter inside, and for the statements belonging to that case label to play a role. Means expression का value case label के साथ match करेगा, so from there we get an entry, and from there the execution will begin. And once the execution begins, the coming out business only depends upon whether we come across and break, or we come across basically an exit. If we don't use this break, the execution will keep continuing and will proceed and will keep entering into subsequent cases. इसको collapsible switches कहा जाता है. The control will collapse into subsequent cases, and also will collapse into default, and then after coming across a main exit, a main closing brace, it will come out. So most of the time we prefer, okay, is like one action per option. So that's the reason break is frequently used, but they're not mandatory, and default is also not mandatory. The default कब execute होता है, my dear friend? When none of the case labels are getting executed, default plays a role. Acha, is it necessary that default should be always at the end? So my dear friend, need not be necessary. Default need not be right at the end. It can be, really speaking, anywhere. It can appear before case 0 also. But then, as it is recommended practice is, if nothing works well, the last option which comes in form of a default, it should be treated as a last option. So default is normally used and expressed at the end of the speech block, and this is how the speech case goes. So going ahead, I don't know. I rather will take an opportunity to ask Mandar sir to intervene, and the one who is hosting, whether I should still continue. Yeah, it is a time for me to take a pause and discuss and try to address some of the queries. Mandar sir, if you can intervene.
Yes, good afternoon to all. I think, sir, you should continue with some questions because
Okay.
we are going to send the feedback link to them now on a chat. So that will be sent by Amit Ailani, sir. And after that, we will give them the link for the quiz also. So for
Okay. Yeah.
5-10 minutes, if you can ask some
Yeah,
questions, or
that's
the
great. That's
students,
great.
if the students, if they are having any queries, they can post their queries or questions on the chat box, so that sir can better answer them directly.
Okay, great, sir.
Okay.
So thank you, dear friends. But then you not asking a query, basically, okay, is either brings a great degree of happiness to me, or is a matter to worry, because you not asking a question possibly is that it is a seamless delivery, and then everything what I have talked about, you have digested in the right spirit and the most elegant manner. But then the other side of the coin is, no, you not asking the question is a matter to worry. It means that you are not at all attending, and we believe, and everyone believes, that asking a query is one good attribute one should have. An ability to ask a question is very much respected. So I take a pause of 1 minute, and my dear friends, my student friends, I appeal you, if you have any queries, you please post, so that will be better, instead of I asking and queries, and then it tends to go in a very unidirectional manner. I take a pause of 1 minute. Mandar sir. So
Yeah, some of them
Mandar sir.
ask the questions. not really related to the topic that we are discussing, but about
Okay.
structures and all that thing. So I
Okay,
already
great.
answered their queries on the chat box.
Great, sir.
Uh,
And then right at the beginning, I also have said we
hmm,
wish to spend less time. That is the reason, in fact. Okay,
correct.
covering up to loop was not, in fact, as per my plan. But then I realized that spending too much of a time on the earlier aspects of C is not good. So I've tried my best. Okay, to
Yes, sir.
speed up.
Definitely. Hmm.
Yes, sir. So I will address those queries later on, and well and good. Mm, so the queries, well and good. I'll say I'll be happy, and my dear friends, you will be responding to simple questions. What right now I'll be posting in front of you in a form of an chat. So at least we'll come to know you're okay with that. So one thing, the very first
Okay,
question is,
one query is there. I can see
uh,
the query. What
hmm,
if we put two conditions in for loop, like I less than equal to 4 and
hmm.
j less than equal to 5?
No, no, you can. Great, and very good question. And this is
This
a
is asked
question
by
which
Avinash.
normally Avinash. Thank you, Avinash.
Uh,
Yaar. Means at least
uh,
one question and done with the day is a feeling for me. Okay, and just wait. I'll prepare. I will show you now. I mean, just wait. So coming to an for loop. For loop, where is that for loop? For loop, huh? So now, is it visible? So you mean if I write down something like this, I is 1, and I'm writing down I less than 3, and j less than 4, something like this. Now my answer to this is, and right now I'll not write down, okay, plus I and whatever, and comma minus j, let it be. Now if you look at this expression, loop condition. So my dear friend, these are not two expressions, this is a single expression. What you've asked me is, this is a single expression, because this expression contains three operators. I we want I less than 3 as well as j less than 4 for loop to continue. So ये loop condition will be true if I is less than 3 as well as j is less than 3, because we are using and. So this is not two expressions. This is a single expression. Now in place of and, if I uses logical or, if I'm using logical, let us assume that I'm using logical or. So the possible intention behind this is, अगर I का value 3 है, या तो J का value less than 4 है, either I is less than 3 or J is less than 4, I want my loop to continue. So still this is a single expression. Now the extreme of this is if I put comma here. Now if I, the way I'm doing it basically, okay, for your expression, let us look at this. So now these are the two expressions, okay, separated by an comma. So now if I'm putting a comma here, comma agar maine dala, so I assume that now comma operator is evaluated from left to right. Are you okay with this? Evaluated from left to right, and the result of the expression is the rightmost expression. So इसमें क्या हो जाएगा? The rightmost expression will be only significant. Means I less than 3 check करेगा वो, comma आ गया, j less than 4 check करेगा, and only the rightmost expression will be playing a significant role. So even if you are allowed to use multiple expression, but the rightmost expression only will be significant for deciding the fate of the loop, whether the loop will repeat or will not repeat. I assume that it goes something like this. Am I right, Mandar sir? Means
yes,
uh,
definitely.
so this is how it goes, Avinash. So thank you for asking the question. And from my side, one question is, I want you to tell me how negative numbers are represented. Chalo, I want you to respond, okay, on a chat. How negative integers are represented, okay, in C language.
Yeah, Aniket is asking one doubt. Sir, can you explain the question again about the specific bit 0 or 1?
I love to, yeah. Thank you, Aniket. And then we will be making this presentation also available for you. I will post this. I will make this question also available to you. I will ask Amit Ailani, who is looking after the coordination part, so that will be made available to you. But then still, as you've asked, questions are very much respected. Okay, very much respected, and that is the reason this is how the question goes. Don't look at the hint, just look at the question. Is it? I think this is visible. So what I can do is that I can. Okay, well and good.
1. Now it is
So
visible.
if you want me to just elaborate on this, so I'll say कि एक number है, hexadecimal number है, and hexadecimal number में our focus is required to be only on bit number 1, 3, 8 and 9. तो यहाँ ये rightmost bit is for us bit number 1, bit number 3 यहाँ जहाँ cursor है, then bit number 8 and bit number 9, and we are eager to know कि वहाँ 0 है या नहीं है. अगर 0 है तो मेरे आंसर में 1 आना चाहिए. कहने के फॉर मी टू से इफ आई फाइंड 0 देयर आई शुड से हाँ का मतलब माय प्रोग्राम शुड डिस्प्ले 1 देयर, एंड इफ 1 इज देयर तो माय प्रोग्राम शुड डिस्प्ले 0, एंड इट मींस दैट कि यहाँ ये केस में बिट पोजीशन 1 पे 1 है. Look at this, my dear friend. I assume that it is visible to you. Bit number 1 position पे 1 है तो my program should display 0, saying that यहाँ 0 नहीं है. And bit number third की बात करूँ तो third number position bit number 3 पे 0 है तो my program should display 1. Bit number 8 के लिए 0 है तो my program should display 1. 9 के लिए my program should display 1. However, when it comes to bit number 4, 5 and 11, if it is 1, I should say 1. If it is 0, I should say 0. ऐसा वो simple program है, and you will be trying this. You can try it by doing bitwise ANDing, masking करके. Your focus should be on one bit position at a time. And दूसरा तरीका है कि you can use right shift operator, keep shifting bit by one position at a time, and then you keep your vigilance and watch only on the rightmost bit. That is how it goes. Is it okay, sir?
Okay. There is one more doubt by Jinal.
Yes.
CHAR function. So he wanted to read the characters or sequence of characters with space, but he wanted to do it with a scanf. He don't want to use get CHR. So he's asking how to do it by using scanf. Reading string with spaces.
String with okay. I'll show you. Thank you. So great. Again, come back. Is it visible, sir? His screen this day?
Yes.
So at the top, I will just start typing. Okay. So I will start typing, and I am assuming that this is visible. So now will be anyhow. This was in a plan. I was about to discuss this, but at the time of string. So if I write down %s and if I write down say str, so this is basically a scanf function to read a string. But the unfortunate part, scanf function being a very versatile function, but the only lacuna and a slight shortcoming of this is, especially when we are trying to read the string, what happens is that %s, if we uses moment it encounters a white space character, the acceptance process stops there itself. So iska matlab hai ki in response to this, if I'm entering a string Sachin space Deshpande, if I enter my full name, so the scanf only will read Sachin, because moment it encounter a space, the acceptance process stops there itself. So now your question is how to overcome this problem. So one way to overcome this problem is obviously is one option is there, which is gets, and I will be writing down str. So this is one function which is more versatile, especially not versatile, I can call it as. It overcomes the shortcoming of scanf, especially when we are required to accept a string consisting of blanks also, but gets possibly will not work on some environments, okay, and platform like Linux. So we have an scanf alternative available, and what I can do is that in that case I will say I will do it something like this. Just wait. I will put square bracket, and I will put this caret symbol, and I will put simply \n, and then I will close. Okay, and percentage. That's all. And this is not required then. So if I'm writing down percentage square bracket may something like that, like this. In fact, this single quote is also not required, I believe. Obviously, S should be small. So what is the meaning of this? As long as we don't come across \n, a new line character, whole of the line we can type. Now this line of text what you are entering may be consisting of blanks and everything. So after we have done with the line, when we hit the enter key, internally \n gets appended for carriage return \n. So \n जब तक आता नहीं है तब तक everything will get accepted. ऐसा उसका मतलब है. Okay, and I can show you the demonstration also. So this is except \n, everything is acceptable, says scanf. And if I write down like this, if I write it like this, square bracket, this is a set of acceptable character. Set of acceptable character. So obviously it should be included within a pair of double quotes, part of syntax. ABCD अगर मैंने लिखा, so I'm saying only ABCD is acceptable. So as long as what you are typing is one out of this ABCD, it is acceptable. If you enter say N, so the acceptance process stops, because now you are saying कि only ABCD is acceptable. और इसको negate करने के लिए to invert this हम लोग use करते हैं, okay, ये. So if I say caret and A, so I'm saying except capital A, everything is acceptable. ऐसा उसका मतलब है. Is it okay, my dear friend? Is it okay?
Yeah. We should go ahead with the next query. The query is by Tariq Sheikh. He is asking the question: what is the difference between including the header file with angular braces and double quotes? What if I write angular bracket stdio.h and when to write double quote file name.h?
One answer to this is especially when you are putting an angular brackets, they are recommended to be used when it comes to standard header files.
Correct.
And if you have created your own header file, or if you have some file basically, okay, where you have proposed some prototypes, and it is there in your working directory right now, local directory, or you also can, this file can be elsewhere, then you need to specify the entire path. So if you want your file, not a standard header file, to be included, it is recommended to be included within a pair of double quotes.
Right. So I guess the queries are over. It was a nice session, nice discussion, and I think the feedback form link is already given in the comment box.
Okay.
So please fill the feedback. That is very important for us. And tomorrow's session will be again. It will start at 11 a.m. It will be on the
Functions
next topics.
And arrays and pointer.
Right.
So thank you, my dear friends. Yes, sir. Thank you.
Tomorrow same response from all of you, and I hope together we will improve, and we will improve our placement area also. So thank you, Deshpande sir. Deshpande sir,
thank you, sir. Thank you, dear friends, and will be trying our best, okay, to whatever is best in favor of you. We are there. And please, I request you all to please go through the quiz what Amit Ailani sir will be sending you. The link will be provided to you, and also keep giving us the feedback where we can improve. So thank you. Good day, friends. Thank you.
We are posting the quiz link here itself. I'm waiting for Amit.
Amit, you can do that favor to me.
Yeah. Thank you. I got the link. I will just share it on the comment box. Right. So this is the link for the quiz. So to attempt this particular quiz, which will consist of many interesting questions, and come up with any doubts in the next lecture. Thank you so much.
Thanks.
So I think we should stop this session,
Conclude.
stop this broadcast. Yes. Thank you, sir.
Thank you.